Okay, the screen sharing doesn't work as usual, so let's remove the speaker mode then. Like, who needs suggestions and cheats that I wrote for myself? So okay, so I'm really happy to be here because yeah, my flight got cancelled 3 times, and I arrived here at 1 a.m. So I'm really happy to be here in general. So let me set a timer so I won't take your time for lunch because no one should listen about functional programming and not having lunch. So yeah, my name is Karin. I'm a senior software engineer working at CircleCI, and today I'm going to talk about functional programming in Kotlin because functional programming is a very hot topic. Like a lot of holy wars, like should we even use the functional topic or every software engineer should definitely use functional programming because it's really fancy, really fast, fits the narrative or whatever, or just because it sounds cool. So object-oriented programming is really old for all people with computer science degrees. So a little bit about myself. So yeah, as I told you, I'm a software engineer working at CircleCI. I have a background in Kotlin, Scala, both on front end and back end, and Clojure. But my primary language is Golang right now, so no functional programming for me. I'm living in Potsdam, and I have two funny cats. So everyone like cats, so they are here with us today. And I'm a Google developer expert in Kotlin, and I had a great experience of teaching Kotlin and especially functional Kotlin to people with strong enterprisey backend background in Java. So yeah, as I told you, I am a backend engineer or full stack engineer, if you like, and not an Android engineer, but I figured out that some practices are still useful for Android, and today I'd like to share them with you. So first of all, why? So as I told you, functional programming is pretty in trend right now, so why not? But for me, the journey started with an interesting conversation on the conference. Well, we were discussing that people are actually scared of functional programming because we can put on agenda a lot of really, really difficult topics about internals of the JVM, and everyone is sure, why not? Sounds like an interesting talk. But whenever there's a word monad in the title of the talk, everyone is like, oh no, monads, I need a PhD to understand that. I'm not going. And I think it's a big problem that people are really scared of functional programming for no real reason. And this is why I'm trying to make this talk work and show that functional programming is quite friendly, or at least is not as scary. On agenda, we are having today the elements of functional programming, monads, so the most important part of functional programming according to the internet. Error handling as a popular example of how to apply functional programming in real life, and a short discussion when to use functional style and when not to use. Can we maybe close this door? It's really loud. Cool. So about elements of functional programming, I have examples in Kotlin and Java. I have a longer version of this talk that also deals with Scala and Clojure, but for Android purposes, I decided to proceed with only 2 languages today. And elements of functional programming. So every software engineer is dealing with complexity every day. We are trying to reduce complexity in our projects and our systems. And to solve the problem with complexity, there are various approaches. For example, the approach of choosing different software engineering or programming paradigm, for example, object-oriented programming, where we are trying to scope complexity to something smaller, so an object. And the same idea is for functional programming. So why elements though? Because it's not like we are writing hello world every time in a purely object-oriented way, and our object-oriented code is really purely object-oriented. It also has some procedural ideas, same as with functional programming. But first of all, What does functional programming consist of? Well, functions. Function is something that is the most important for us. Those functions are pure, having no side effects. I'll talk about this a little bit later. They are evaluated in a lazy style, so they are calculated only where we need them and not when we declare them. Also, the important concepts are immutable data and the lack of the global state. So let me take some water. So about pure functions. Those are the rules. So I'm not trying to give you strict academical definitions, but those are the rules for the pure functions. So first of all, same input means same output. For example, imagine a function that adds 1 to every integer. We know that when we are passing 5 to this function, we will get 6. And for 6, this function will yield 7. And every time we are passing 5, we are getting 6. Every time we are passing 6, we are getting 7. And that is for every possible parameter for this function that we can expect. Another one is side effects. So side effects, you can imagine as something that is outside of our control. Imagine when we are writing something to the database. So AWS, for example, may be down. Like our database may not be available, or like we don't have a console to write our logs at all. So this is something outside of our control. So side effects. Side effects are mostly I/O related. So yeah, in a pure sense, you cannot really write logs because it's a side effect. But this is like a really important thing to understand, which is that elements of functional programming, not pure functional programming. So you won't like tell the business like, okay, I'm not writing logs anymore and we are not storing any data in the database because like it's not pure enough. Like, no, it's not working. We are the engineers and we have to deal with real life sometimes, which is sad, but we have to adapt to the reality. And the third rule is we shouldn't be altering or having any global state in general. So this is about the functions and about immutability. Those are some concepts from Java that you may already seen. So like Java has records, final keyword, var library. Kotlin has vals and vars, so val read-only collections, Kotlin X collections immutable, and also arrow library for immutability. But not every immutability is created the same. So let's call them true immutability and reference immutability. So you can see an example here of defining a final list. So it's final, using arrays as list. And while we cannot reassign it, so the reference is final, so it's here, we can actually modify the content of the list. So the reference is immutable, but the content is not. There are some ways to avoid that, but in general, yeah, you have to understand with which immutability type you're working with. The story with Kotlin is exactly the same. We have 3 types of immutability here. So first of all, mutable collections that are marked explicitly with mutable, collections that you cannot modify but someone else might do somewhere, and truly immutable collections from Kotlin X collections immutable. So since we cannot modify our collections, for example, what can we do with them? So we can create new collections and using some transformation functions for that. The first of all, and the most important one, is map function. So a map function takes a collection and maps every element one by one. So the size of the newly created collection is exactly the same as the old one. So for example, here we are mapping frogs to unicorns. And as an example, you can see the short versions of doing that in Kotlin and Java. In Java, though, all those interesting functions for working with collections are located in stream API, so the syntax is not so elegant as in Kotlin, so you have to keep in mind in that. So now when we have map, what can we do with collections also? We can filter them. I personally don't like the word filter because it's never clear if we are keeping the elements or if we are removing the elements that match the predicate. In Kotlin, in Java, and I think in most languages, it's the keep filter. So whenever we are passing the predicate is frog, we are keeping the frogs, not the unicorns. Yeah, again, stream API and casting to list if you have to put it into list back. More tricky one is fold. So fold is something that you're doing when you have a collection and want to like put the result into a single element, for example. I don't know, maybe a more real life example will be calculating a sum when you have a collection with numbers or something like that. Typically, fold in Java and Kotlin also has an accumulator, a starting element. So for the sum, when we are calculating the sum of the numbers, our starting element will be 0 because we can add everything to 0 without changing our output. But if we want to multiply our numbers, we will start with 1. Otherwise, by multiplying by 0, we'll get 0 every time. So in Java, it's a little bit tricky. Java doesn't have like fold explicitly, but has collect with collector. A typical collector that you probably already seen is to list. But in general, you can write your own. So it consists of 4 parts. The starting element, how to combine two elements, how to create the next step, and some action in the end. So for example, you can do, I don't know, to string. And the last but not least is a flat map. So flat map looks something like map, but with flatten operation. So whenever we are mapping our square onto the list of heart and circle, after mapping, we will have like a list of lists, but then we are flattening it to a single list, so like removing by the boundaries of the nested lists. So you can imagine like you have the box with the boxes and removing the content from the inner boxes and throwing everything in the bigger box, and that's it. The flat map is actually a really important concept for functional programming on the scale. So this is the flat map for collections. But how can we benefit from using it? Let's take a step back first and talk about monads. So like monads are a pretty simple concept. Like a monad is just a monoid in a category of the endofunctors, or so do the people from Scala meetups tell people on the first slide. I'm not sure why, because I don't know. I have a degree in computer science, but I'm not exactly sure if this like a good opening slide for everyone. And I figured out that it's easier to tell people by example. So like, what is a monad? So like, do you know monads? Probably not. But have you used list? Sure, and that's a monad. And the question is, why is it a monad? Because if we won't deep dive into academic definitions, there are also monadic laws, but let's not look into them. A type or an instance of which can be created and which has a flatmap function is a monad. So for example, list is a monad and it has a flatmap function. So of course, for every type of monad, there's different way of writing a flatmap, but you can start with a list. So what else is a monad? That's a really good question. And let's take a step back into error handling and actually start with Java. So whenever we want to tell that something may go wrong in our program, we will write something like, if something is wrong, throw a new exception, and that's totally fine. Then we will handle it somewhere in the signature via throws, and handling it somewhere later in a try-catch block. And that's totally fine. Yeah. Let me change the microphone. Thank you. Yeah, let's see if it works better. So yeah, and let's do it in a and let's handle it in a try-catch block later. So totally fine, nothing wrong with that. We are really modern people. Let's use Java 8 at least. Like, we are not working in the bank, hopefully. So let's do it via Stream API because it's more beautiful. So taking an in-stream range from 0 to 10 for each and using our test function that throws some exception looks really great, but it isn't working. Why? Because you cannot put the function that throws exception just like that in Stream API functions, because you will have to handle it somehow here. For example, you can put a try catch right here, right in the place of test fun, and that's, well, that works, but I wouldn't like to see that anywhere. So typical pattern for that is hiding or like wrapping the exception into like the function that throws a checked exception into another function that doesn't, and then unwrap it back. So it's like a really typical pattern, but sometimes I would like to see explicitly that something may go wrong. So what are our options? So in Kotlin, the problem is quite simple. So like checked exceptions are gone, and we are just rewriting it as for each and calling our test fun without any problems. But still, I really want to see sometimes that something in this place may go wrong. Some functions in the standard library are dealing with that using null. So for example, the functions for string like toInt or null are returning either int or null. So int in case of success and null for everything else. So
And the switch back again.
okay. Okay, let's try again. So the functions like this are returning, for example, integer when the int could be parsed from the string, and null when everything else happened. It's great for the simple cases, but the problem sometimes is I'd like to know what exactly went wrong. So for example, from toInt or null, problems may be, for example, a string is not a number at all. So like the word cat is not a number. Or it could be parsed into a number, but it's too long, so it doesn't fit into integer. But still, for both cases, I think we will get null. And maybe in some cases it may make a difference in our flow. So what else do we have in Kotlin? We have a result type, which is quite greedy and catches everything, that can be thrown through this code. So we don't really get more information that from null, and it's just a convenient way to write something that for the code that throws something. But I personally don't like run catching because it's like really greedy. And one time I had an interesting experience of debugging, run catching, consuming, and hiding from all of us out of memory error. And that's not fun. So, okay, if not run catching, what else? If we have a situation when we can say, okay, there are results A, B, C, D, and nothing else, we can explicitly list them. For example, imagine I'm an investor. So I know if I buy some stocks, I will either lose money or I will get some like really big profits, or like financial crisis happened and like no one has any money at all. So, but there is like a finite number of of outcomes, and we can explicitly list them. And what interesting, if you can list all of the outcomes, it's a really popular pattern. So, for example, for to int or null, you can say, okay, the outcomes are one positive, we parsed an int successfully, like it's a string, we cannot parse it. It's a number that is too long, we cannot parse it into int. And in this, when you're listing the outcomes, you can often notice that there is a single positive outcome and multiple negative outcomes. And for that, in functional programming, we are using the thing called either. There is no either in the standard library or of Java and Kotlin, but you can either write your own or use one from Arrow or Vowr. And either is a structure that is typed with two types of failure and success. The mnemonic here for right is right. So on the right side there is a type that you will get in case of success. So for example, integer, int. And on the left is everything else. I don't know, null pointer, exception, whatever. And what's interesting in either, it also has a flat map, which means either could be used as a monad. So for collections, flat map is quite straightforward. But how does a flat map for either work? It's quite simple. Flat map is used to chain eithers, and it works in the following way. So if in our chain there is an either that will result in write, so for example, we are doing multiple DB calls, and let's say we retrieved user successfully, right? Stock info also successfully, so we can continue doing the next call. But whenever we didn't succeed with that, so for example, for stock info, the database wasn't available, we are getting left. As a result, we are stopping all calculations and saying, okay, no, the end result is left. We cannot do that. And well, this sounds interesting, but doesn't really look beautiful. So like, what's the catch? And if you ever tried Scala, in Scala there is a pattern called monad comprehension, and there is a similar one in, for example, Arrow. You can define a common context, for example, either, which is a monad, and just do all of your calculations without unwrapping or like chaining via flat map. Just don't forget to use bind function to keep the context. But in general, so you don't need to unwrap anything here. It's already in your context pretty unwrapped. And for multiple calls from the database, it's really convenient, in my opinion. So for conclusions, so like the good news, you're already using elements of functional programming. So like final vols, collections, maps, likely. So elements of functional programming are already in use, so it's not scary. The second one is consider the support of libraries. So it's not the biggest problem for Kotlin, for example, because Arrow is pretty well-maintained library. But for example, for Clojure, some libraries are a little bit outdated, and for Clojure, another problem will be find the people who write Clojure. So you can invest in months of teaching people Clojure, but sometimes you need solutions right now and not in years. So whenever you're considering switching to functional programming style, in my opinion, it's worth switching step by step. So introducing, for example, iders in your error handling, and not like rewriting the entire project, or maybe not even starting the whole project from the scratch. Which is why I think it's important to consider team knowledge, because every project is quite unique. So if you have to teach people, you should understand if you have the capacity for that or not. And the fourth speculation, if immutability is slow, it's really interesting because typically if you can find the benchmarks in the internet, they're comparing something like sorting, and the problem is you won't write sorting in the same like algorithm or in the same way as an object-oriented or procedural programming. So those benchmark, while they're saying like, okay, it's true that immutable collections are a little bit slower, and if you write a sorting algorithm in a functional style, it may be quite slow, but it's not like you're writing the code that way in production. This part is really important to know. So, yeah, I'd like to stop here for today. And if you're interested, I have also the talk that compares Clojure and Scala with Java and Kotlin in the same context. So check on my GitHub if you're interested. So yeah, let's go to the questions if we have any. And then lunch.